All right, so we're going to finish up on unit circle trig. So what we've done so far, draw this and we'll just put a circle. What were the first 4 angles on that circle that we found coordinates for?
90, 180, 270, 360.
90, 180, 270, and 360. Yeah. Yeah. So 0, 90, 180, 270. Okay, and let's just review. What was the coordinate for 0 degrees?
1, 0.
Yep, 1, 0. And coordinate for 90 degrees?
0, 1.
0, 1. Okay, how about 180?
Negative 1, 0.
Negative 1, 0. And 270?
0, negative 1.
0, negative 1. Yep. So we had those 4. And then yesterday we added in the 45, the 30, and the 60. So 30, 45, 60. What was the coordinate for 30?
Square root of 3 over 2, 1/2.
Yep. So that's the root 3 over 2, 1/2. What was the coordinate for 45?
Square root of 2 over 2, square root of 2 over 2.
Okay, square root
Set that over.
2 over 2.
Is that you? Sorry.
Square root 2 over 2. And what was the coordinate for the 60?
1/2. Comma 3 squared. Or not 3, square root of 3 over 2.
Yep, 1/2 square root 3 over 2. All right, so those are the coordinates we've done so far. Today, we're going to look at doing the 30, the 45, and the 60 in the other quadrants. But as long as you know what the coordinate is in quadrant 1, it's very easy to do it in quadrant 2 or any other quadrant. So here's a 45 flipped into quadrant 2. It's 135 degrees. It's just like 45, except reflected over here. So what do you think the coordinate for 135 would be? Based on the fact that it's just a mirror image of this triangle on that side. I didn't sketch it perfect, but yep.
Negative square root of 2 over 2, and then comma square root of 2 over 2.
Yep, negative square root 2 over 2 because you went left, and square root 2 over 2 up. So if that idea makes sense, then all the angles that we do today are going to make sense. All right, so let's take a look. So now we're going to find the 6 trig functions of any angle that is a multiple of 30, 45, and 60. Maybe we'll review one from yesterday, but then the rest will be multiples. So angles like 120, 150, 135, 225. Okay, those are all multiples of 30 and 45. Now, if you have an angle that's not a multiple of 30 and 45, like let's say I said to you, let's find the sine of 15.7 degrees. Well, that's not an angle that you're going to be able to do on the unit circle. So when you get an angle that you can't do on the unit circle, we are going to, we're going to use the calculator. So at the end of the lesson, I'll show you how to do that in the calculator. Nice. Okay, so the coordinates that we had yesterday, we're still using them today. Still using the 30, 60, 90 and the 45, 45, 90. The only difference is we're going to be reflecting these triangles into other quadrants. Okay. There's the 45 reflected into every quadrant. Okay, I'm not going to draw every triangle reflected in every quadrant because then it starts to, the diagram starts to get too much kind of going on. But that's the 45 reflected in all the quadrants. This is 225. And this one is 315. Those are your 45s. All right, so let's try 135. So it says to find the 6 trig functions of 135. All right, anytime they ask you to find the trig functions and they give you an angle, what is it that you need to really figure out?
Or the coordinate.
You need the coordinate. Yep. So what we want to do is graph 135 on the circle. So there's 0, 90, 180. And we're basically going to have 3 choices where we put 135. We know it's between 90 and 180. But is it closer to 90? Is it closer to 180? Or is 135 right in the middle? It's right in the middle. Yeah. If it ends in a 5 for the ones we do, it's going to end up being right in the middle. Okay. So let's mark 135. And we got to figure out the coordinate to get to that point. Well, let's look at this triangle. Let's look at the 135. What do you add to 135 to get to 180? You add 45. So from here to here is 45 degrees. That means from here to here is also 45 degrees. So this is a 45. And all the angles have to add up to what? 180. They all have to add up to 180. So we got a 90, we got a 45. And what does the one at the top have to be? Has to be a 45. So that proves that we're using the 45, 45, 90 triangle again from yesterday. How long is each leg in the 45, 45, 90? It's isosceles, so they're the same. Yep.
Root of 2 over 2.
Yep, they're both root 2 over 2. And change a different color. Root 2 over 2. When we write the coordinate, though, we just have to be careful because we went left and then up. Okay. So what's going to be the coordinate for 135? I mean, we know how far over to go, and we know how far up to go. Just make sure that we go left.
Negative root 2 over 2. And then root 2.
Yep, negative root 2 over 2, root 2 over 2. So regardless of what trig function I have you do on the test, that's the first thing I'll ask. What's the coordinate for the angle you're trying to work with? And then I'll ask you for one of these 6. All right, so let's go through them. How about, Jaden, what is the sine of 135? Can you say it again? Square root 2 over 2. Yep. Okay. Alex, what's the cosine?
Cosine is y over 2, right?
No, cosine doesn't use y.
Is it x over 2 then?
Just x. Yeah, no over. No over.
Square root 2 over 2.
So it's just negative square root 2 over 2. Okay, so there's my cosine. Alex, how about my tangent?
Negative 1.
Yeah, tangent's going to be y divided by x. Well, they're opposites. When you divide opposites, you get negative 1. All right, and Jacob, once I get the 3 on the left, what do we do with them to get the 3 on the right?
We have to use the radicals.
No.
You have to flip each one from the top to the bottom. I forget the name of it.
Yeah, just flip them.
Yeah.
Yep, just flip each one. So let's do the cotangent first. If you flip negative 1, what do you get?
1 would be negative 1, which would still be negative 1.
It would still be negative 1. Okay, so that one's the easy one. How about the cosecant? When you flip square root 2 over 2,
Square root.
b squared. It's just square root of 2. So we've done that one a few times. You flip it, the square root 2 goes to the bottom, and then you multiply by the square root, and that gives you 2 root 2 over 2, and then the 2's cancelled.
That one's negative. It's still negative.
Which one?
Oh, I was thinking the flipped x one.
What trig function are you thinking of? I'm not sure which one. How do you say that one?
Secant?
Secant, yeah. So the secant of 135 would also be negative root 2. Yep. And that's because you're flipping the same thing you did up above, except it has a negative in front. And those are the 6 trig functions of 135. I think that's the only one we do all 6 today. I think after that I just asked for one at a time. Any questions on that one? All right, so let's try a few others. So cosecant of pi over 4. All right, so you tell me, what do you think you should do first? Yeah.
Convert it to degrees
All right, why are you changing to degrees?
so we can find the coordinates easier.
Okay, so we can find the coordinate easier, sure. So that's going to be the cosecant of, what did you say pi over 4 is?
45 degrees.
That is 45 degrees. Okay. And now, what is the coordinate for 45 degrees? Yep.
Square root 2 over 2, square root 2 over 2.
Square root 2 over 2, root 2 over 2. Okay, I know cosecant is one I have to flip. Is it I know they're the same, so it doesn't really matter, but is it the x that you flip or the y that you flip? It's the y. It's the y. So we're flipping that one. And when you flip root 2 over 2, you get
Square root 2.
square root of 2. Right, so we didn't really need the sketch this time. Any question on that? Let's try this one. Sine of 225. All right, so I don't think there's any need to change the angle. It's already in degrees, so that's good. Where's 225 going to be on the circle?
Third quadrant.
Yep, it's going to be in the third quadrant. Is it going to be closer to 180, right in the middle, or closer to 270?
Right in the middle.
Yeah, 225 is a multiple of 45, and 45s are always right in the middle. So there's 225. So we could make a triangle out of it. And we have to figure out how long this side is and how long that side is. What kind of triangle is this? The 45-45 or the 30-60?
45.
It's the 45-45 because the angle we're working with is a multiple of 45. It's not a multiple of 30. All right. So that means since it's the 45-45, how long is each leg?
Square root 2 over 2.
Yep. And both square root 2 over 2. Now, when you write your coordinate, just be careful because you are in the third quadrant. So what does that mean about both the x and the y?
Both x and y are negative.
They both are negative. So left root 2 over 2, down root 2 over 2. And that's the coordinate for 225. Okay, and what's the sign going to be?
Root 2 over 2.
Yep, and which one did you pick, just so I know?
The line.
The y. Yep, sign is the y gun. Okay, hopefully you've noticed by now, we don't do any decimals with these. Okay, we always would leave it just like that. Don't divide that. Okay, questions on that? All right, let's try 7 pi over 4. Well, let's start with this. We did that earlier. What's pi over 4?
45 degrees.
It's 45. So this is definitely a multiple of 45. It's 45, and it's the seventh multiple. It's 45 times 7. So we need to figure out what 45 times 7 is.
1260.
How much?
1260.
I got 315.
Oh,
Yeah. Should be 350.
I had multiplied it. Yeah, 315.
Yeah. Okay, so 350. All right, so let's try to narrow down where that is. What quadrant is 315 in? Second. So these are your quadrants. Yes, it's in the fourth quadrant. That's 270. That's 360. Where's 315? Closer to 270? Right in the middle? Closer to 360? It's right in the middle. And anytime we've got something right in the middle, that's always which triangle?
45, 45, 90.
Yep, it's going to be the 45, 45, 90. So both sides are root 2 over 2, because it's a 45. And what's going to be my coordinate?
Square root 2 over 2 negative square root 2 over 2.
Yep, this time only one of them is negative because we went right. That's positive, and then down. So negative. Now they are different, so if you mix them up, we're going to get it wrong. Okay. What's the cosine of 315?
Square root of 2 over 2.
Yes, cosine is the x value of your coordinate, which is root 2 over 2. Okay, so we did the 45 in every quadrant. So any questions on the 45? All right. 120. Just looking at that number, is 120 a multiple of 45?
No.
Is it a multiple of 30?
Yes.
Yeah, it's 30 times 4. So this is going to be the 30, 60, 90, which means when we draw it, it's going to be closer to one of the axes. It's not right in the middle. All right. Let's start with the quadrant. 1, 2, 3, or 4.
2.
Yep. It's in the upper left. That's quadrant 2. Here's 180. There's 90. So is 120 closer to 90 in the middle or closer to 180?
Closer to 90.
This is closer to 90. You draw it closer to 90. Make your triangle. And if you do it right, it should definitely look like one side is longer than the other. You should have a short side, and then you should have a long side. So now the sides are different numbers. In the 30, 60, 90, the short side is always what number? 1/2. 1/2. And how about the long side?
Square root of 2.
Perfect. So you don't necessarily have to memorize all of them. If you can make a picture, you can just look at the picture and see. All right, so the short side's 1/2, long side root 3 over 2. That's good. How about the coordinate now for 120 degrees?
Negative 1/2. Square root 3 over 2.
Negative 1/2, square root 3 over 2. And now the tangent. What's my formula for tangent?
Y over X.
Y over X. 3 over 2 over negative 1/2. Okay. What happens when you divide those?
The 2's cancel.
2's cancel. So those are gone. And what are you left with?
Negative root 3.
Negative root 3. Yep. That's the answer. So again, 2 things I'd ask for. What's the coordinate? And then what's the answer?
Wouldn't this be a multiple of 60 and not 30 because the 60 is mirrored, the 120 is mirroring the 60?
I guess it just all depends which angle you're thinking of it from. So this is the 60 down here,
Right, that's what I'm thinking of.
and that's the 30 up there.
Mm-hmm.
So As long as you understand it's the 30, 60,
Yeah.
90. Yep. Yep. But yeah, it is more like that would be the 60. And that would be your triangle. Yep. So it's like a mirror image of that one. Yep. All right, let's look at this one. Secant of 690. All right, well, first thing is there's something I don't like about 690.
Larger than 360.
Yeah, it's larger than 360, so we never want to work with an angle larger than 360. What can we do to make it smaller?
Subtract 360.
Subtract 360, and that gives me 330. Do I want to subtract 360 again?
No.
No. If I do it again, it's going to go negative. So we don't want to deal with negative angles either. So 330, that's good. So the secant of 330 is a simpler way to write down what they're asking. Okay. What quadrant is 330 in? Yeah, it's fourth quadrant. It's almost all the way around. So here's 270. Here's 360. Where's 330 in that quadrant? It's close to 360. Yep. Let's put it right there. Make your triangle. Okay. And we definitely have a long side and a short side. Okay, let's do the long side. Lance, what's the length of the long side? You want to help him out? What's the length of the long side in the 30, 60, 90?
Square root of 3 over 2.
Square root 3 over 2. Okay, how about the short side?
1/2.
The short side is always the 1/2. Okay. So what's going to be my coordinate for 330? Or 690? Same thing. Yeah.
Square root of 3 over 2.
Square root of 3 over 2. And what was the second number?
1/2.
Yeah, negative 1/2. 1/2 would be 30. That negative makes a pretty big difference. It's 330. Okay, so secant. That's one of the ones we gotta flip. What do you flip to get the secant?
Square root of 3 over 2.
Yep, you're gonna flip the x. So it's gonna be 2 over the square root of 3. And how about when you clean that up?
It's just a square root of 3.
2 times the square root of 3 over 3.
2 times
yeah.
the square root of 3
That's right.
over 3. Yep. Any question on that one? All right. Okay, I guess I have one more. Try one. Let's at least get it in degrees, and then if we want to find the cosecant, we can. Let's start with this. What's pi over 6?
$30.
That's 30. And what's 30 times negative 7?
Negative 120 degrees. Sorry, negative 210 degrees.
Negative 210. Okay, so it's 30 times negative 7. All right, I like it because it's in degrees, but I'm still not crazy about that angle. What do we want to do to that? Yep.
At 360.
Yep, I would add 360. So take negative 210, add 360, and now it's 150. You should be able to tell looking at that now if it's either a multiple of 30 or 45. Which one is it? 30. Yeah, this is going to be the multiple of 30. So any question on how you would get the coordinate for 150 now? And then get the cosecant. Everyone will be okay finishing that one up. So I'm going to show you a picture that basically has all 16 points on it. So there's a lot going on in the picture. All the red triangles are all the 45s. Okay. Root 2 over 2, root 2 over 2. Sometimes they're both positive, both negative, or one of each. All the green triangles are your root 3 over 2 1/2. Sometimes, again, both positive, both negative, or one of each. And all the blue triangles are the 1/2 root 3 over 2s. So really, these are the only coordinates you need to remember for the 30s, 60s, and 45s. Everything else is just a mirror image of that. Yes?
Can I take a picture of that?
Sure.
I'm going to write it down.
Remove the circle before we take a picture.
Yes, I can remove the circle.
Thank you.
Yep.
Mark G. Progress.
So if you
Write that down.
if you look at that, you count it. There's 3 points in every quadrant. There's 1 on each axis. That's a total of 16 different points. And I could ask you one of 6 trig functions for each one of those coordinates, the sine, cosine, and so on. Right? But that's everything you can do with unit circle trig as far as 30s, 60s, 45s, and the quadrants. Again, notice the ones you're missing. You're missing this one to make them all equally spaced, and you're missing that one in every quadrant. Might have said it, but what do you think that one is?
15.
That's a 15. And how about that one?
75.
The 75. If you know how to do the 15s, then there's 2, 4, 6, 8 more coordinates that you can do. You don't get to the 15s. It's a formula that we just probably won't get to in this class. Thank God. But if you can do the 30s and 60s, the 15 is actually very easy. If you can do 30s and 60s. Yes.
Aren't 15s just half of the 30-degree angles?
Not quite. Well, I mean, yeah, 15 is half of 30, but you wouldn't be able to just take half of each of those numbers to get the coordinate. The coordinate's a little more complicated to figure out than that. It ends up having, if I remember right, square roots of 6, square roots of 2, and I think a 4 in the denominator. Sometimes it's plus, sometimes it's minus. It depends on the quadrant. But it involves square roots of 6 and 2s. All right. So, what I want to look at is the same formulas that we've been doing all week. You're going to have one for sine, cosine, tangent. But instead of writing the formula specifically for a unit circle, we can do it on a circle that's any size. Unit circle, I think the formula is the simplest, just because the r is a 1. But if r is not 1, that won't stop us from doing it. So let me show you the kind of question I'm going to ask you and then why we're going to need this formula. I'm going to ask you about the point 512. I'm going to ask you to do something with the point 512. Now, think about the point 512. Let me put a grid up. And I want to look at that coordinate. Let's do... There we go. I don't think the medium one goes to 12. No, it goes to 10. Oh wait, does it go? No, going up it goes to 10. I need more going up, so I gotta do this one. Alright, so 512. Okay, so write 5, 5, 10, 12. There's the point 512. Okay, that point is going to be on the edge of a circle, just like we've been doing all along. question is that point on the unit circle? No. The unit circle is a tiny little circle right there. It goes 1 unit in every direction. That's way off the unit circle. So if you have a point that's not like a square root of 2, a square root of 3, or a 1/2, it doesn't have one of those numbers we've been using, it's probably not on the unit circle. It's going to be off of it. And you can always just take a piece of graph paper and check. If you have a point that's not on the unit circle, instead of having the sign be y, it becomes y over r. Okay. What was cosine on the unit circle?
X.
It was x. Well, now it's x over r. What was tangent on the unit circle?
Y.
It's y over x, and that one actually ends up being the same. That one doesn't change. Now, once we get the 3 on the left, what have we always done to get the 3 on the right? Flip them. So what do you think the formula for the cosecant is going to be?
R over Y.
Yep, on a circle that doesn't have a radius of r. A radius of 1. It's r over y. How about the secant?
Over X.
It's r over x. And the cotangent?
X over Y.
X over y. Yep. So those are the formulas to do trigonometry on any circle. Not just a unit circle, but any circle. Now, don't do what I'm about to do because it'll mess up your notes. Just watch this. I'm going to erase all the r's and I'm going to change them to 1s. Okay? Watch what happens if I do that. If I change all the r's back to 1s, does anybody recognize what those are now?
Unit circle.
That's the unit circle. Those are the formulas I taught you on Monday. So the formulas I taught you on Monday were really, go back, these formulas. The only thing that I did to make it easier is I let r equal 1, because 1's an easy number to work with. But I could have let r equal 2, or 3, or 5. I could have used any number. But we've been practicing when r is 1 all week. Now we're going to practice when r is not 1. Any question on that?
So it's just better for our eyes.
It's an easier way to start, yes. Yep, it's one less thing you have to think about. Because in this circle, you have to figure out, well, how big of a circle is it? Normally it's 1. Well, that's not 1. It's a lot bigger than 13. Why do you say 13?
I don't know, I counted blocks.
You count on the angle you
Oh,
count.
yeah, that doesn't help.
Well, no, I counted the blocks on left to right because the radius doesn't change when it's angled. It's still 13 blocks.
Exactly, that's why I did it.
Oh, okay.
So
I
I
got
came
you.
up with that answer.
Yep. So you counted 13.
And the radius doesn't change on a circle when you spin it, so it's
Yep.
going to be 13 up to the
So it is going to be 13, yes.
So that's that. So 12.
So let's say we didn't have a diagram though. You didn't have graph paper to sketch that. Anyone have a thought what kind of shape you could make?
Triangle.
Yes.
Triangle.
If you make a triangle out of this, you got that side, and you got that side. The bottom, remember what this coordinate was. What was this coordinate?
5, 12.
5, 12. How long is the bottom side?
5.
5. And how about the height?
12.
It's 12. The radius of this circle is the hypotenuse in that triangle. If you know the two sides, how do you find the hypotenuse?
A squared times.
Pythagorean theorem.
Yeah, the Pythagorean theorem. So 5 squared plus 12 squared equals c squared. What's 5 squared?
25.
25. 12 squared?
44.
And what do you get when you add those together?
169.
And then when you take the square root on both sides,
13.
13.
Who did that?
Oh, we already know what that.
So
Oh yeah.
that's the only extra step when you have to do trig on a circle that's not a unit circle. You still know the x, that'll be given. You're still gonna know the y. You just have to figure out the r, or the hypotenuse of the triangle. And that's it. Alright, let's try, well, I guess we can do the 512. We kind of already know what r is. So 512, somewhere up there.
It looks like 30, 60, 90 triangle.
It probably won't be a 30, 60 exactly, because usually when the angles are nice in the triangle, then the coordinate is not nice. So because this is a nice coordinate, the angles are probably pretty messy. All right, so let's write everything down. What's the x value they gave us?
5.
5. What's the y value?
12.
12. Is the point 512 on the unit circle?
No.
No. Then you cannot use the formula we learned on Monday. What's the size of the circle that it's on?
13.
13. Now, you're ready to figure it out?
What if we didn't know what the size was of the circle?
Well, you have to figure out that size, the size of the circle. Yeah, you have to figure that out. Okay.
So either way, it's either going to give you the radius or it's going to give you whatever you just did.
It's always going to give you these.
Oh, all right.
It'll always give you two numbers for x and y, and then you have to find r if you're not on the unit circle. If I give you points like 1/2 and root 3 over 2, we already know those are all in the unit circle.
Yeah.
So you don't have to worry about r.
Yeah, but say like you gave us, like 4, 10.
Then you gotta find r.
Yeah.
Because that's way
Just plug it into the size of your Pythagorean theorem to find the radius.
Yep.
All right.
Go to, just sign out. Okay, so let's start with sine. Sine is y over r. So what's the sine going to be here? 12 over 13. Okay.
Do you just want us to leave it like that?
Yes.
Okay.
Yep.
Over here, but to divide it up.
Yeah.
Cosine is x over r.
5 over 13.
It's going to be 5 over 13. And the tangent is the same formula, y over x.
5 over 12. Sorry, 2.45.
What is it?
2.4.
12 over 5.
Right.
Y over x, 12 over 5.
Yes.
Everything should always just stay as a fraction.
Okay. All right. Good to know.
And then if we wanted to do the cosecant, the secant, and the cotangent,
Oh, that makes it really easy.
we just take those and do what? Flip them. There's no roots. So 13 twelfths, 13 fifths, 5 twelfths.
Oh, nice.
You know. Okay. So any questions on those formulas up above? And so they really are the same formulas you learned on Monday. It's just I'm not letting r be 1. I'm letting r be any number. All right, so that allows us to do trig on a circle, but we still either have to be given the coordinate, or if we're not given the coordinate, it has to be a 30, a 60, or a 45 multiple. If you have an angle that's not a multiple of 30, 45, or 60, you can't do it using any kind of circle with trig. I mean, technically, you could do the 15s. You can technically do half of anything you already know how to do. So if you know how to do a 30, you can do a 15. If you know how to do a 15, you could do a 7.5. Right? You can always do half of what you know how to do. There's a trick. But we're only focusing on the 30s and 45s. So if you don't have a 30 or 45, then we're going to use the calculator to figure it out. All right, so let's look at sine of, well, actually, you tell me, how do you read that?
The sine of 18 degrees.
The sine of 18 degrees. So the last thing that Sean said, very important, it's degrees. So because we're going to do this on the calculator, I need to be in degrees. Okay? If I type it in right now, I'm doing the sine of 18 radians. That's not what the question is asking. So change to degrees.
How do you do that?
So you press mode, and then it's the fourth option down, and then you just pick degrees. If it doesn't say degrees at the top, you are not in degrees. It needs to say degrees.
Mine's already in.
Yeah, it might already be in it. It'll stay in the last mode that somebody put it in. Yep. All right, now is 18 a multiple of 30? No. Multiple of 45? No, that's why we're using the calculator. And all we do is round this off. These are the ones where it is okay to round. So we'll just put 0.31. If they wanted 3 decimal places, we'd go 309. So 0.31. All right, let's try this one. Okay, what does that one say?
Cosine of 356 degrees.
356 degrees. Okay, still in degrees. So what would we get when we type that in?
Point.
Or like 0.9975.
All right, so 0.9975. I'm going to go to 3 on that one just so we don't round it up to 1. So 0.998. $356 degrees. That's getting pretty close to what degree? 360. The highest you can ever get when you take the cosine is 1. It never goes above 1. When you get to 360, it's exactly 1. Well, what happens when you go past 360? Like, what do you think will happen at like 371 or 361? Yeah, it starts coming back down. So yeah, there is a symmetry there. 361 and 1 are the same. 362 and 2 are also the same. But it never goes above 1. All right, so it's cosine 356 degrees. What does that one say?
2.4 radians.
That's the tangent of 2.4 radians. The absence of a degree symbol automatically means you need to be in radians. Okay. So go to your mode, put it in radians, tangent 2.4. And you should have gotten negative 0.916. Wow. Any question on that? All right, so that's the sine, the cosine, and the tangent. What are the other 3 that we have?
Cosecant, secant, cotangent.
All right, so we have the cosecant, the secant, and the cotangent. All right, let's try the cosecant. First of all, what should I do on my calculator?
Switch it
Back to degrees. Yep.
How you gonna flip it?
So yeah, how am I going to type in cosecant? I don't have a button for it.
Second and above the one we're trying to.
We're going to talk about that. Somebody brought that up at the beginning of class. That's inverse trig, when you have that -1 there. I know normally a -1 means to flip something, but when you see that in trig, it does not mean to flip it. This is a totally different thing called inverse trig.
Maths now obliterate.
We'll talk about that next week. How have we been finding the cosecant all along?
Can we just put in like 1 divided by 1 divided by, is it sine?
Yes.
1 divided by sine and then did it?
That's how we've been doing the cosecant all week. We've been finding the sine and flipping it. Do it the same way here. We're going to find the sine and flip it. So that's how you can do it all in one step. If you don't want to do it in one step, you could find the sine of 247 first, and then tell the calculator to flip it by doing 1 divided by the last answer that was on the screen. Okay, I usually just do it all in one step. So negative 1.086. Okay, so that's cosecant,
Wait, you did one divided by
the sine.
the sine.
Yep, because when you flip the sign, you get the cosecant.
Okay.
Okay, let's do, just because the last one's in degrees, and I'm in degrees, I'm going to handle all the degree ones first. Okay, cotangent of 13 degrees. How would I type that in?
So it'll be 1 divided by tangent
1 divided by the tangent
13.
of 13 degrees. Yep. So that's taking the tangent and flipping it. So 4.331. Okay. And the last one. How would you read that one?
Secant
6 radians. Yep. So to radians. And how do we type in? Let's see. Secant.
1 divided by cosine.
Yep, flip the cosine. So 1.01, no, 1.041. Okay, so the only time that you'll use the calculator is if it's an angle that's not a multiple of 30 or 45. Okay, so that's unit circle trig. Trig on really any type of circle, and then how to use the calculator. Any questions on that?
When you did the tangent, did you put it back to radian?
When I did the tangent, I left it in degrees because it was in degrees.
We switched it to radian because you gave us the.
Because we did secant 6 last.
Okay.
Yeah.
Okay.
Yeah, when you change the mode, it won't go back and change the answer that's already on the screen. So like if I change mode back to degrees, nothing changed on the screen. So it won't go back and recalculate what you've already typed in. If you put it in the wrong mode, you got to type it in again. And the quick way, if you press second enter, it'll bring up the last thing you typed in. So if you need to keep going back, you can type in. It'll go back. I don't know how many it goes back. It might go back 50 calculations or something.
Never knew that.
Yep. All right. So the homework for tonight, it's 49 to 57 odd. 67 to 81, that's all. And you need a calculator for every one of those. Those are all calculator ones. And then 83 and 84. I think that's the trig on a circle that doesn't have a radius of 1. Okay, so you've got about 20 minutes. So please use the time to try to get started. I will be available if anybody has questions. Tomorrow, review day. Make sure you bring your Chromebook. And then I will be after school as well.